Sorry. Oh, this one is able to. Right? Okay. Where are they going? Okay. I don't know whether this will balance it. Okay. And see. So, more balance like that. This one is not so easily done. You see? Oh. So you can see now that this center mesh of this two forks is somewhere here in the air. And then in fact it is directly below the pivot. So what we are going to do now is we are going to burn this. Burn the stick and see what happens when I burn this. Alright. What do you think will happen if I burn this? You think it will fall? And where do you think it will burn up to? Yeah, you will burn up to there. Huh? Let's see. You probably take a minute or two. Let's switch on the aircon. Can you see? The fire is going to go up. The fire is going to go up. Oh, it went out already. Let's put more. Oh, now you got bigger fire. A bigger fire, and you will burn. It will burn, and then you will find that when it reaches the pivot, then you will stop burning. See? When it reaches the pivot, it will stop burning. See? Let's have it burn faster. Burn faster. Burn faster. Oh, is it going to topple over? It will not, huh? It will not topple over. Which means that the center of mass of this toothpick plus the two fork is directly below the pivot here. And it's actually very stable if I move a little bit. Can you see? It is very stable, right? Yes? Can you touch softly? See whether you keep it softly. Yeah, there. It's just like the 2 coins, right? It's just the 2 coins. Remember, this came out as a past year's question at O levels, where they asked MCQ A, B, C, D. C and D was one of them. The center of mass combined is at the pivot, or the center of mass is below the pivot, and the answer was below the pivot. You know the Chinese acrobat, they have got a bicycle, someone on the bicycle, right, on a tightrope. And then below that bicycle, they have got some swing where somebody can sit there. And therefore now, because somebody sits there, somebody heavy sits at the bottom below the tightrope, the total center of mass of the bicycle plus the passenger there below the tightrope is directly below the tightrope. Okay? The tightrope. So if they were to go a little bit towards the side, it will swing back and then you will still remain at the bottom of the tightrope. And therefore, that is a very stable kind of arrangement. But most people do not see it to be below the pivot. They think, in TikTok, they also think that it is at the pivot, but it's wrong. It's a wrong answer. Okay, this is nice. This is nice. Now, since we are burning things, let's burn this candle. Okay? Let's burn this candle. See whether you remember this or not. I may or I may not have shown you this.
You did.
I did. What did I show?
You put the water.
Okay.
You covered it.
Yeah.
Wait, you cover first, then you put the water, then you.
Yeah. And then what happened?
You lit the candle before.
I light the candle, and then what
Then
happened?
the water rushed up to about.
Yeah. Then so I put water. Okay. I put the water there. So the water is there. So what do you do? What do I do? I have this, right? Now this, notice that I put 20%, 40%, 60%, 80%, 100% volume, the internal volume. Okay, you put it on like that. Yeah, put it all the way in, and you find that, oh, never mind. Hey, and the water will rise about 20% here. Can you see? Which means that all the oxygen was burned up by the candle and then converted into carbon dioxide. Carbon dioxide dissolves in water much faster than oxygen. So all the carbon dioxide that was produced has now been dissolved into water. So there is a partial vacuum here, and therefore atmospheric pressure will press down on the outside to push the water into the cup. Okay? So now, when this one stops rising to about 20%, this is about 20%. Can you see? It's about 20% here. Then the pressure inside the cup, the air pressure inside the cup, inside the glass, is equal to the atmospheric pressure, and therefore the water stops rising up to about 20% of that. So that the atmospheric pressure inside the glass and outside the glass will be the same. So there will be no more movement. So this proves, in a way, what does it prove? That oxygen consists about
20% of
about 20% of air that we breathe. We cannot breathe air which is very rich in oxygen unless you have COVID. So when you have COVID, they put you on the oxygen tank because you don't have enough oxygen in your lungs for the oxygen to go into your blood. Okay, when the blood comes up from your heart, not enough oxygen for it to diffuse in and carry to the left side of your heart to be pumped all the way around to your brains and the rest of your body. Okay, now we are at burning. We are at burning. Oh, did you bring back the pump? You didn't? Okay. Let's pump this, okay? What am I going to do? What am I going to do? What do you think I'm going to do? Okay. You hold one balloon. Open the other one and pump another balloon. Yeah.
open.
Yeah, open. Pump another balloon.
How big?
Yeah, pump another balloon.
Pump how big?
As big as all the way here, all the way here. Okay, pump another one. Before you pump the next one, what I want you to do is to pour in some water inside the balloon and then pump. Okay? Pour in some water. Yeah. Pour in some water, then pump. Yeah, try. Oh, you need a teaser funnel. You need a separating funnel. You need this. No? You need. Okay.
Pour all.
Wait. Yeah, okay, enough. Yeah, pour some more.
Pour all.
Yeah, pour all. Okay, then now pump.
Pump until this size.
That one never mind.
Pump until this size.
Yeah.
Also.
Pump. Other. No strength. Pump harder. Okay, you videotape. I pump tape on you. Okay. Is there water? There is water slushing inside. Okay, so what we want to do now is to do something related to heat. Something related to heat. So we're going to put several experiments into one video. Okay. Now we are going to see what will happen if I hit this balloon. If I hit the balloon, put a candle here. Okay. What do you think will happen if I put this balloon over it?
You expand.
It will burst. It will not burst. This balloon,
Expand.
it will burn. Okay, let's see. Let's put it here. It got a shock. And what about this one? This one also no water.
You burst.
It will burst rather than burn. Okay, it will burst. I suppose it can burn if you let it stay there long enough. Okay? Like if you let it stay there, then it will burn, right? Huh? Can it burn? Yeah, it will burn. Huh? The balloon will burn. See? The balloon will burn. Okay. So now if we do not let it stay there long enough, then let's try it again. Okay. Now this one has water slushing inside. And now, because there's water inside, the water has the ability to draw the heat away from the balloon. So you think it will burn? It will burst? You think it will burst? No? You think it will burst? The water inside, huh? Okay. Now, see. It will not burst. Yeah, you see the water took the heat away from the balloon. Is that clear? And the water inside here is supposed to have a high heat capacity. Can you see? And then you will not burn. And you will not burst. Yay! Yeah. Alright. The next video that we're going to do is we're going to talk about ignition temperature. You know what is ignition? Ignition means to ignite, like this. This one will ignite and then it burns, okay? Ignition. Of course we tell people not to practice this at home without knowing the danger. Okay, let's stop for this.